Let's take a look at what we already know about the dilation rules. We covered actually some of this material back in the very first couple of sections about isometries and so on. And what we learned is that a dilation will have a constant number a scale factor that will multiply times the x value, but it will also multiply by the y value. Now, where I want to change this slightly is I want to think of run and rise as kind of that x value, the run being the x and the y being the rise. So same idea, but I want to focus on the terms of run and rise. And I'll show you why in a second, because it's going to help us. So when we perform a dilation, here we are centered at O here, so let's highlight that. O being the origin. And we decide to dilate it by 2 times. What I want you to think about is that it will be 2 runs. So there's a run there of 4, but it would take another run of 4 over here. So when we think about 2 times the run, think of it as going over once and then going over a second time. We're also going to do 2 times the rise. So whatever this one is, we would do this. We kind of did this with the previous lesson about centers, but I want you to think about dilation as how many runs and rises you want. If this was a 3 in these positions, we would do another run and another rise to obtain the prime of that particular item. What I want you to think about is 1, 2, 3, basically that idea of how many rise and run opportunities there are. Now, when you're dilating out of the origin, that whole idea of scale factor is very easy, actually. Again, it's how many runs and how many rises you have. So think of the x as runs. So this is just 2 times 3, negative 3 is negative 6. And 2 times 5 is 10. It's just simple multiplication when we're operating out of the origin. 5 times 2 is 10, and 5 times 8 is 40. And then here, 1/3 of 6 is 2, and 1/3 of 24 is 8. Now again, a way to think about that, though, is to think of it in terms of slope. So let me show you this problem right here as in terms of a picture. So here's your graph here, and you're out of the origin, and 2 and 8 is, let's say here, this is 2 and 8. Now, you know there's a ray that goes through that, right? We're going to operate on that ray. Now, here's the way to understand why it's just simple multiplication of 5 times 2 and 5 times 8, is I want you to think about it as 5 runs and 5 rises. So 2 and 8, that would be 1. And then we do it again, 2 and 8, that's 4 and 16. You would do it again, that would be 6 and 24. You would do it again, and it would be 8 and 32. And then you would do that one more time, and guess where you would land? At 10 and 40. So I need you to kind of envision the idea of what a dilation is basically multiplying by the runs and the rises. A dilation is just simply moving up and down a ray using that concept of slope. So just to recap before we do the more complex environment, if you're dilating out of the origin, the dilation rule is quite simple. It's the scale factor times the run, and it's the scale factor times the rise. Very easy mathematics, right? Just multiplying 2 numbers, basically. So the more complex environment is when we are not centered out of the origin. How do we dilate, or what does the rule look like? All right, let's take a look now at a rule when it's not based out of the origin. Don't worry too much about what's up top there quite yet. I do want to look at the dilation that we're doing. So this tells us we're going to dilate out of T, so that's our center. and our dilation is going to be 2. So let's create our array there, and we'll do our best to draw that nice straight line. Now, I want us to think about the way dilations work. And we do know that if you're scaling by 2, we were saying that we think of it like 2 runs and 2 rises. So that's the same. So if we were trying to do this, we could do it by 2 runs and 2 rises. So let's try. This run here is 5, and then it rises 2. And then we could go 1, 2, 3, 4, 5, and then rise 2. This would be the result of where H prime would land. Because if you think of dilation in terms of runs and rises, really all it's instructing you to do is start at this point and do 5 over and 2 up, 5 over and 2 up. So you end up doing the run twice and the rise twice. This is exactly what we were doing before out of the origin. The only difference is that we are starting at a new location, which is the A and the B component of this. And so why we didn't have an A and a B before is because we were at the origin, and so it was 0 and 0. But if we move anywhere else, you just start from the X and Y values of our center point, and then you do so many runs and so many rises from that location. So it's basically the same formula, but we're starting in those 2 new locations. All right, let's do one. And I've kind of created it so it's laid out for us to go step by step, just because this is our first time. Let's remind you that the way we're going to think about this is K runs and K rises. And that basically we're going to start at whatever that center of dilation is. So in our case, the center of dilation is G. So the A and the B will be that 1 and that 3. Now to do this, we're going to need to know the run and the rise. So let's calculate the run. The run is the change in the X values. So in this case, that would be 6 minus 1. And you would always do it in the order of the point to the center of dilation. So 6 minus 1 and 5 minus 3. The order in this case matters because it determines kind of a direction as well. And so we get to 2. So again, let's get a little picture of what this might look like. Here we are at 1 and 3, and here we are at 6 and 5 over here. And the idea is we are going to dilate this 4 times. So you know what that means. It means runs of 5, rises of 2, and we would continue to do that on and on and on 4 times in total. But we can do the actual math without having to draw the picture. So notice we're down here, we have a 1 and a 3 as our values. The reason we have the 1 and the 3 is that that's what our center is. And then, as you know, we're going to do so many runs and so many rises. And so all you and I have to do is put in our run count of 5, put in our rise count of 2, and do the math. This is 1 plus 20, so 21 would be the value there. And this is 8 and 3 make 11. So if we were to do this starting at 1 and 3, and we did 4 runs and rises of that type, this is exactly where it would land at 21 and 11. Let's try that again. Here is our center, and so you'll notice down here we're going to start with a 2 and a 7 because those are our centers, our X and Y. We have a count of rise and run. So again, we need to calculate our run count. So it's going to always be the one minus the other. So -1 subtract 2 is a -3 count. And 1 subtract 7 is a -6 count. Now maybe let's draw that picture if we can, just kind of rough it in so you can kind of see what this would look like. We're at negative 1, 1 here, and 2 and 7 kind of up here. And so we are going in this direction, but we're going to scale it 1/3 of the way. So it's going to kind of land maybe somewhere in this area, being 1/3 of that value. Let's see what we get for an answer. So I'm going to put in the run of -3, and I'm going to put in the rise of -6. And if we do the math, 1/3 times -3 is -1. So 2 minus 1 is 1. And if we do this math, that's -2, so 7 minus 2 would be a 5. And so it would land kind of where we were kind of guessing it out a little bit at about 1 and 5. So this was a contraction or a reduction because of the 1/3. And again, maybe in a better diagram situation, we had this kind of thing happening where this was our center. We were dilating something up here, and we did 1/3 of that, which landed us about here, which is at 1 and 5 as a value. The key is to find your rise and your run, and then place them into that little relationship. Let's take away all the extra help and just do it from scratch. Here is our center that we're going to work from. Let's find our run. So it would be -7 subtract a -4. That comes out to be a -3. And let's do our 3 subtract 1 is a 2 value. So here is my run, here is my rise. What I've learned is I start at the center of dilation, which is a 4. My scale factor is -2 of the runs. Let's start at the 1 because that's the Y value, and let's do -2 of the rises. And this represents kind of the calculation. Again, let me just highlight some things here for you. Where did this come from? That's this guy right here, the -4. Where did this come from? That's the 1 from there. Where did the -2 come from? That's my scale factor in both cases. And then where did the -3 come from? That was my run. Where did the 2 come from? That was my rise. And now we just do the math. This becomes +6, so that's a 2 overall. This becomes -4, so 1 minus 4 is -3. And then this becomes the location of the answer. One last one quickly. I know I need to do this, though. People struggle with this one. Here's my center. Here's my scale factor. Let's find our run. That would be -1 subtract 2. That's a -3 run. It would be 1 subtract 7. That's a -6 rise. I start at 2 and I start at 7. These are my locations here. My scale factor is a 5. And so I'm going to scale 5 runs and 5 rises. In this case, my run is -3, my rise is -6. And so let's do the math. And the math is simply, this is -15. So this becomes -13. This is -30. So this is -23. There's your answer. That's how you dilate from any point in the plane